So now we're going to do a trig sub. And du equals 2 cosine theta. So we get 4 minus 4 sine squared theta in the square root. Du becomes 2 cosine theta d theta. I can factor a 4 out from the square root, becomes a factor of 2 outside, multiplied by this 2 here. So I get the integral of the square root of 1 minus sine squared. And then outside cosine theta d theta. Okay, let's scooch it over here. So let's see, we've got 4. And remember, integral, or the square root here, this becomes square root of cosine squared, which is cosine. So I've got cosine theta times cosine theta. So we get the integral of cosine squared. And okay, again, we've seen this integral already today, so let's do what we know we need to do, right? Cosine squared is 1/2 1 plus cosine of 2 theta. 4 times 1/2 is 2. And here when we integrate of theta plus sine of 2 theta over 2. Okay, and then what did I do with sine of 2 theta? So that's 2 sine theta cosine theta. So it cancels out the 2 downstairs. Okay. Now let's draw our triangle and then get everything back to the original variable. So let's see, where did we substitute? So yeah, we did u equals 2 sine theta. So sine of theta equals u over 2. So we're going to put u on the opposite side, 2 on the hypotenuse. Okay? And so our adjacent side will be the square root of 4 minus u squared. So for cosine of theta here, we can use the adjacent over hypotenuse. For theta, remember, if I solve for theta in this equation here, we get theta equals sine inverse of u over 2. So let's see, we got 2 times sine inverse of u over 2. Sine theta was u over 2, so plus u over 2 cosine theta square root of 4 minus u squared over 2. Okay, but remember, we got to go back to x, so let's replace u now with x plus 1. And then we're done, right? So let's see what we get. Sine inverse of, let's see, u was x plus 1, so we'll have sine inverse of x plus 1 over 2. Plus, let's see, u was x plus 1 here, so we'll have x plus 1, and then 4 minus the square root of 4 minus x plus 1 squared. Square squared, and then all over 4. And we're done. So yeah, these are good examples to pay attention to because, okay, it's just, again, manipulating the integrand to get it into a form where now I can use a trig set, right? So any questions so far?
Question on this, completing the square. If we put 1 minus 1, what would happen if we made it 2 and then like a 1 minus x squared? If we made the 3 a 4, we could have gone the other way, right? And made 3 a 2 and had 1 minus x quantity squared.
I don't see how that
where 3 plus 1 minus 1 is 2x minus x squared. What if we had like 1 minus 2x minus x squared, and then you just change that to 1 minus x squared? We wouldn't get the 4 then, I see. We need the 4 to have a square.
No, I mean, that's not important. What's important is that this is a perfect square binomial, right? There should really only be one unique way of completing the square properly. Well, actually, let me think about that. So, wait, let me get this straight. You're saying
It's like 1 minus 2x minus x squared. Isn't that the same thing as 1 minus x? All of that squared.
so. Okay, well.
And isn't that the same thing as open parentheses 1? Oh no, that's where I'm caught wrong. I think 1 minus x.
So, okay, the important thing here is that it's got a positive x squared term to make it a perfect square.
That's where I went.
Yeah. Yeah, I mean, I think, I think you could think about completing the square in different ways, and you know, let me think of it this way. Actually, to be more systematic about it, what you should do is rearrange the terms in standard form. Okay, if you have a leading coefficient on x squared, factor it out from all the variable terms. In this case, I've got a -1 coefficient. Factor that out just from the variable terms. Okay, leave myself a little blank spot inside there. And so there I've got the right x squared plus bx, and okay, I take half of my middle term, take half of 2, and square it and get 1, right? So that's what I'm going to add here. Okay. However, since I had a negative out here, right, that we factored out, this is really a -1, right? So I just added a -1. So we've got to add a +1 out here to balance it out. Okay, that's the right way to think of it. So yeah, you get the same result here: negative x plus 1 in parentheses squared plus 1. So yeah, any other questions? I don't think I have time to do another one, so so let's call it there for today.
Where's on this one?
Right?